Yeah, okay, we're ready. Hey guys, today we're going to talk about application for magnetic,
Electric,
and gravitational. Oh, camera.
blame gravity.
Cars are the quintessential display of how man can make amazing things. Ferrari, Audi, Cadillac, and Chevrolet are a few of the leaders in the automotive industry, producing one car after another, each one better than the last, equipped with the most updated and developed automotive technology suitable for their car's purpose. Out of the many wondrous technological systems that makes a car great, a car's suspension system plays a significant role in providing the handling, safety, and comfort for the passengers. But ride comfort and handling has always had to be compromised, as they are both interrelated. So, is it possible to eliminate this need for a compromise between these two important factors in the quality of a car ride?
Hey, I'm Diana. Hey, I'm Xiaoyao.
Hey guys, I'm Zari.
And we will be your automotive suspension experts.
What comes to mind when we mention automobile performance? Horsepower, torque, 0 to 60 acceleration. Impressive stuff, but all this power generated by the piston engine is useless if the driver has poor control of the car. Because of this, automobile engineers turn their attention to the suspension system almost as soon as they have mastered the four-stroke internal combustion engine. Invented by Nicholas Otto, 1876. The first shock absorbers were simply two arms connected by a bolt with a friction disc between them. The bolt was tightened and loosened to adjust resistance.
But, of course, due to the immense friction the system creates, these shocks were very durable, and the performance left much to be desired.
But that was ages ago. The suspension system we see in cars today are much more advanced. For example, the hydraulic, hydropneumatic, and hydrogas suspension system.
The suspension system performs 6 basic functions.
To maintain correct vehicle ride height and to reduce the effect of shock forces, to maintain correct wheel alignment and support vehicle weight, as well as to keep the tires in contact with the road and to control the vehicle's direction of travel.
So back to the question, is there a way to eliminate or at least reduce the need for compromise between ride comfort and handling quality?
Introducing magnetic
Right!
suspension. The magnetic ride suspension is a type of semi-active suspension system that uses a magnetoreological fluid in its shock absorbers. These fluids contain ferromagnetic particles that align themselves in the presence of a magnetic field, resisting fluid flow and thus creates damping with higher efficiency. It is a suspension system in which its mechanism uses electrical energy for the transfer of signals and magnetism to create a suspension reaction on the car, thus defying gravity through the means of suspension. So, electric, magnetic, and gravitational fields are all applied in magnetic ride suspension. The universal law of gravitation states that
An apple. Thanks. There's a gravitational attraction between any two objects.
a massive object in the Earth's surface experiences the Earth's gravitational pull.
A suspension system allows the body of a car to resist the pull of gravity. Since the forces acting on the car are balanced, the downward force of the gravity has been defined.
I think I tried defying gravity, and you can't pull me down.
Basically, a car's suspension system works to maximize the friction between the car's tire and the road surface. The friction will result in better steering control, stability, as well as ensuring the passenger's comfort.
Vehicle dynamics is a study of the forces acting on the vehicle partly due to road conditions and vehicle motion. Now, let's look at a situation where a car drives over a bump on the road. The car's wheel would experience a vertical acceleration due to irregularity. Because of this, the wheel loses contact with the road and thus the driver would have less control of his car. Gravity then pulls the car to slam back onto the road surface. So, a suspension system is needed to absorb the shock that would otherwise be strongly felt by the car's passengers.
The suspension also works to reduce the body roll, especially when the car is cornering. Body roll happens on the body of a car when centrifugal force push outward on the car's center of the gravity. In response to this, the suspension system reacts by the shifting of the weight of the car so that the body of the car is leveled when making the turn.
When an object is suspended, the forces acting on it are balanced.
Net force 0!
The downward gravitational forces cancel out, and hence, the object won't fall due to gravity.
Superhero says,
With great power comes great responsibilities.
We say,
with great suspension system,
comes complex control systems.
the magnetic ride suspension is a system driven by a complex control system which is allowed the quick changes of damping from soft to hard or any stages in between. It adapts damping effort in response to signals sent from a control unit in the form of electrical currents, which receives commands from the car's electronic systems.
The system responds in real time to road and driving conditions, based on inputs from sensors that monitor the body and the wheel motions, providing a fast, smooth, continuously variable damping action. It's a simple, cost-effective, and reliable package.
The system consists of 4 magnetorealistic fluid-based monotube dampers, a sensor set, and an electronic control unit, or ECU, and is known as a closed-loop system since the flow of input and output is in a loop.
The ECU monitors the car's dynamic state and receives input from a sensor set. With the information received from the sensors, the ECU computes the optimum damping force for a specific driving situation and changes the current supply to the respective dampers.
It also decides the time for the corrective signal to reach the shock absorbers, with the ability to modify the damping characteristics up to 1,000 times per second.
Magnetic ride suspension also had a wide range of damping force control, a high bandwidth for fast response, and a low power requirement of no more than 20 watts per damper. Compared with currently available technologies, the magnetic ride suspension can achieve a much broader damping range and respond more rapidly without generating noise.
Fully software tunable damping characteristic of the magnetic ride suspension provide the excellent low frequency body motion control without the traditional compromise of the excessive impact harshness at the high damper velocities. So, we can say that the electric part of the system is the bridge between gravitational fields and
Action of the magnetic ride suspension system occurs in the MR shock absorbers itself. Let's see what's going on inside. So, basically, the mechanism of the MR shock absorber is very similar to that of a regular shock absorber, but it is in fact simpler, as it does not require the usage of valves. The shock absorbers are filled with MR fluid, a smart fluid containing micron-sized ferromagnetic particles that are polarizable when subjected to a magnetic field.
Ferromagnetism means magnetic like iron. Ferromagnetic materials are normally not magnetic but can be induced to become magnets. These materials are composed of tiny magnetic domains which acting like tiny magnetic bars.
Less than 1 micrometer. So small.
These domains originally have random organization, but once they are exposed to a magnetic field, the material become magnetic lah.
The MR fluid is also used as construction materials for buildings in earthquake-prone regions. This is because its flexible properties allows the building to withstand the seismic waves of an earthquake. Whoa!
From the signals transmitted by sensors that control a magnetic field during an earthquake, strategically located in the structure of the building, the MR fluid changes from solid to liquid. In this state, the MR fluid acts as shock absorbers and reduces damage. Well, these structures are called smart structures.
As the shock absorbers compresses, the MR fluid within will move through the channels in the pistons, and as the fluid gets restricted through the channels, the force is dampened. How does this happen?
Inside the piston, which is connected to the shock absorber body, is an electromagnetic coil. When a current is passed through the coil, the magnetic field is produced and we can determine the direction of the magnetic field using the right-hand rule.
In the presence of a magnetic field, the ferromagnetic particles are polarized. These tiny particles will line up along the magnetic field, and hence they will make this fluid thicker and more viscous in the regions surrounding the piston.
As a result of this, the movement of the piston is restricted as there is very limited space for the fluid to pass through one part of the shock absorber to the other, and so the motion of the piston is dampened.
The greater the current supplied to the coil, the stronger the magnetic field. This causes the iron particles to have stronger alignment, which result in greater resistance, hence the greater damping power is produced.
In magnets, unlike poles attract and like poles repel.
Just like positive and negative charges!
Hey! Why are you so sad?
Because I'm a failure.
Oh, no you're not. Come on, I'll help you out. Come on.
Life is so boring.
You are boring.
Oh, and you're not?
No, I'm not.
Why are you so negative?
You're higher, so negative.
Go away!
Fine.
Fine!
Oh, hi there.
Hi, how are you?
I'm awesome. How are you?
Awesome! Everything is awesome!
Everything is awesome. Everything is cool when you're part of a team. Everything is awesome.
Magnetized ferromagnetic particles now each have north and south pole. So, between these particles, there are bound to be attraction and repulsion between two poles. Due to the vertical position of the shock absorbers on the vehicle's chassis, repulsion between like poles that are also in vertical position to each other would result in suspension since the particle on top is against the downward force of gravity.
Yeah, all three fields are totally interrelated in the application of magnetic right suspension, with the electric field acting as a bridge that connects the action and reaction between gravity and magnetism.